So we'll have a look at binary multiplication, and it's worth remembering, it's quite important, that a shift of a number to the left multiplies it by 2. So here we have the number 1010 in binary, which equals 10 in decimal. But if we shift that number 1010 and then fill in a gap, that number is 16 and 4, so that is worth 20. So that's called a bitwise shift. If we shift a binary number to the left, it doubles. So that will come in handy when we are doing multiplication. So we'll have a look at some examples. So in this example, we have 1101 times 10, and the top number is 8 plus 4 plus 1, so that's 13 base 10 times 2 and base 10. So we know it should equal 26. And the quick way to do this, because the 1 on the bottom here is worth 2 and there's nothing else in the units, all we're really doing is multiplying by 2. So we could shift the number to the left and the answer would become 11010, and that is correct, but I'll just take you through the process. So start with the multiplying the 0 part, the units. So 0 times this number is clearly going to be 0 anyway. Next we look at this number, but because this number is in the second column on the left hand side, what we could do, like we do in base 10 multiplication, we put a 0 to shift the answer, and then we just say 1 times 1 is 1, then 1 times 0 is 0, 1 times 1 again is 1, and 1 times that 1 is 1. So if we had a non-zero part here, we would add the two numbers together, but this is a really easy one. So let's have a look at what our answer is worth. So we have in the answer box, 16 plus 8 is 24, plus 2 is 26. So that is correct. But just worth noting that if we're multiplying by 10, as in multiplying by 2, we just shift the number one place to the left and put a 0 placeholder. So in example B, we have 10111 times 11, and I'll split it up as usual into the units and the 2's. In base 10 would be doing the units multiplication, then the 10's multiplication. We put the answers in separate boxes, and then the bottom one is where we add our different answers together. So really straightforward. 1 times the number is just going to be the same number. 1 times 1, 1 times 1, 1 times that 1, 1 times that 0, and 1 times that 1. We expected that. And of course, from what we showed a few minutes ago, now we're multiplying by the 2's, which is what would be the 10's in base 10, would multiply by the 10's next. But why don't we put a place value 0 to move the result over to the left? Now instead of saying 2 1's is 2, we can just say 1 times 1 is 1, and then again, and 1 times that 1, and 1 times that 0, and 1 times that 1. And we're finished. And next we have to add the two answers together. And if you haven't seen the binary addition video, then you need to look at that first. We've got 1 plus 0 is 1, 1 and 1 is 2, and 2 of course looks like 10 in binary. Now we've got 1, 1 and 1, which is 3. 3 looks like 11, so we carry the 1. Now we've got 0 and 1, which is 2. Now we've got 1, 0 and 1, which is also 2. Now we've got 1 and 1, which is 2 again. And remember, 2 looks like 10. So bring that 1 up, and that is our answer. Hopefully the answer is correct, so let's check. Units, 2's, 4's, 8's, 16. So the top number is 16 and 4 and 2 and 1, which is 23. Base 10, the second number is 3. So we're multiplying, so it should be worth 69. So let's see if it is. Remember, the answer overall is the sum of the two products that we did. So the 0 would be worth 0.32s, and that 1 is worth 1 lot of 64. So our answer is 64 plus 4, which is 68, plus 1 is 69. So we've got it correct. 64 plus 4 plus 1 is 69. So that's definitely correct. So all I did was multiply by the first unit, and obviously 1 times a number is going to be the same as what the number was in the first place. And then we did 2 times, which is effectively shifting the number over and making a placeholder. So in the next example, we have 11101 times 110, but there's no point in multiplying by the 0 and putting it in an answer box, because we know 0 times something is 0 anyway. So we're going to move straight on to this column, and when we move on to the next column and multiply, we will put a placeholder to shift it over correctly, and then just say, instead of saying 2 times 1, just say 1 times 1 is 1, 1 times 0 is 0, 1 times that 1 is 1, 1 times 1 is 1, and 1 times 1 is 1. So that's that part done. And as we expected, this answer is the top answer shifted over 1 place to the left, because we were multiplying by 2, and times 2 in binary is a shift left. Next we'll do the same. So this is, instead of multiplying by 4 every time, we will now put 2 zeros in our answer and say 1 times 1 is 1, 1 times 0 is 0, and then 3 ones next to each other. And of course, if we look at the top number and the bottom number is 11101, which is the same as the top, but shifted left twice. And a shift left twice in binary is multiplying by 4, because it's multiplying by 2 twice. Next, all we do is add the two products together. It'll be worth putting 32 up there, 64, and depending on the carry, we may need a 128th column. So the first answer is here, the second answer is there. So 0 and 0 is 0, 1 and 0 is 1, 0 and 1 is 1, 1 and 0 is 1, 1 and 1 is 2, which looks like 10 in binary, 1 and 1 and 1 is 3, which looks like 11 in binary. Now we have 1 and 1 is 2, and we bring that 1 up. So the answer did overflow into the 128th column. So we're expecting our answer to be 120 plus 54, which is 174. So let's see if the answer is worth 174. Well, we've got 128, and we've got 32, and we've got 8 and 2 and 4, which is 14. 128 plus 32 is 160, plus 14 is 174. Happy days. So the things to remember: always give yourself enough space when you're working these out. If you're multiplying by a 3-digit number, you're going to need another 2 columns at least, possibly 3 in your answer, so leave some space. And remember that multiplying by a 1 in this column is just the same as 1 of the number in the answer. Multiplying by a 1 in this column, which is multiplying by 2, just means you take the number, shift it left and put a 0 in the placeholder. And multiplying by a 1 in the third column means you shift the original number to the left twice, and so on. If we had a 1 in the 8th column, we would shift the number 1, 2, 3 times. So hopefully that was useful, and as ever, have a go yourself.